Big happy Friday. Made it 7 weeks. Jeez. Good morning. Okay. I could feel like a good morning. I'd be down with going back to sleep. Okay. Well, let's roll through this. This should be pretty quick today, and not overly complicated. Just a brief extension from what we learned yesterday. This is gonna be a napping stream, dude. I think it should be. This past 3 days, I've been so tired. I can't shake it. I don't know what's going on. I've been sleeping pretty normally, but I'm so tired. Megan would win that. No one can keep up with Megan's napping. Lee says you have COVID. Shoot, probably. I think the cure is probably to eat more hint of lime chips, so I'll try that, see if it helps. Okay. Let's roll through this warm-up. So, number one, what is the limit as x approaches 2 of f of x? Well, this is just asking about the limit. It doesn't say the left-hand limit or the right-hand limit, right? Because there's not the little plus sign or minus sign here. But in order for the limit to exist, that means when we do the left-hand limit and the right-hand limit, we would get the same thing. So as we approach from the left, I'm still screwing this up. Okay, so as we approach from the left, so we put that little minus sign there at 2. So this would be equal to 3. As we approach from the right, so we put the little plus sign there to show that we're approaching from the right. That would be positive 2. Right? So we can see that our two limits, the left-hand limit and the right-hand limit, do not equal the same thing. Okay, therefore this overall limit, dne, does not exist. All right, the only way that we can get a limit is if the two sides are the same thing. Number 2, is f continuous at x equals 3? Justify your answer. So, to be continuous, we need to look at, again, the left-hand limit and the right-hand limit. So as x approaches 3 from the left, so approaching 3 from the left, That would be right here, which would be 3. And then as we approach from the right, same thing. That would also equal 3, so that's a good start. So we know the limit, the overall limit equals 3, since the left hand and the right hand limits equal the same thing. But then we need to actually find the value of the function as well. So f of 3. So f of 3 is actually this point, which is 3, 3. So since all of these, we get the same value, then we can say yes. F is continuous at x equals 3. Since the limit, since the limit equals the value of the function, since they both equal 3. Now it doesn't mean that they have to equal 3. It's just a coincidence that these numbers are both 3, but what's important is just that we get the same thing, whatever it is. They could all equal 1,000, who cares? But since the limit equals the actual value of the function, then we say yes, that it is continuous. And again, looking at graphs, it's much easier to determine why, or like if it's continuous or not. Okay, so let's talk about evaluating limits, either one-sided or two-sided, algebraically. So if we're trying to find a limit, the first thing that we should always just try to do is just plug in the value, right? It's not different from just, finding the value. All right, that's what we'll try first. If that doesn't work, we can try a couple of other things. We can try factoring. Maybe if we factor and cancel some things, then it'll work. We can also try rationalizing the denominator or rationalizing the numerator. Okay, either way. So let's do some basic examples. So find the limit as x approaches -4 of f of x. So here's f. So the limit, right? Why it was lacking? What do you mean? What's he trying to say? First thing, we'll just try to plug in the value. So -4 plus 4, -4 squared minus 9 times -4 minus 52. The numerator, -4 plus 4 is 0. The denominator, so this would be 16 plus 36 minus 52. Did you just have a stroke? Oh, skipping. That would also equal 0 in the denominator. So 0 over 0, well, 0 in the numerator, that's fine, but 0 in the denominator, we cannot divide by 0. So just plugging in the number didn't work. Now, it should always be the first thing we try. But since I end up dividing by 0, I have to try one of my other things. So we can try factoring. We could try rationalizing the denominator. Since this is a polynomial, let's try factoring. So x squared minus 9x minus 52. This would factor into x minus 13 and x plus 4. And so, yeah, we can see then these x plus 4s would cancel. Just leaving me with 1 over x minus 13. Okay, so now let me try to do the limit. So the limit as x approaches negative 4 of, now I know that this expression simplifies into 1 over x minus 13. So 1 over negative 4 minus 13. So negative 1/17. So there's the value. Okay, so our first attempt of doing algebraic limits is just plug in the value. Plug in the number. See if it works out. If it does, then great. That's just whatever that number is. If it doesn't, we might need to do some factoring. We might need to do some rationalizing. We might need to do some other tricks that I'll teach you about. And actually, in calculus, specifically this, whenever we see 0 over 0, we'll learn a specific trick that we can do that will help us out a lot. But this is something special that I've circled here in pink. This is called an indeterminate form, which we'll use a really cool rule on called L'Hopital's rule. But for now, factoring works out enough for us that we're okay with that. Find the limit as x approaches 7 from the left. Okay, now remember, whether it's approaching from the left or approaching from the right, or if it were just as x approaches 7 in general, we're still just going to try the same thing, which is let's plug in 7. So 3 over 7 minus 7, but that leaves me with 3 over 0. Yikes. Okay, so again, we can't divide by 0, and I can't factor here or anything, so I'm kind of stuck. But let's actually then start to think about what this could actually mean. So I'm going to make a small table here. Right, so let me think about what happens to this function as I plug in numbers that are closer to 7, right? Because this is saying as x approaches 7. So as x gets closer to 7 from the left. So let me start by plugging in 6, right? So let's say 3 divided by, well, wait. Yeah, 3 divided by 6 minus 7. So that's 3 divided by negative 1. So negative 3. But what about if I plug in, so let's get closer to 7 from the left. So let's say I plug in 6.5. Okay. Then we get negative 6. Okay, what about if I get closer to 7? So 6.9. So 3 divided by 6.9 minus 7. That would give us negative 30. And let's get closer. 6.99. Negative 300. All right, let's get closer. 6.999. Right, negative 3,000. You can kind of see a pattern emerging. So let's say I even get closer, 6.9999. Okay, so as I get infinitely closer, you know, if I keep adding 9s here, 6.99999999999999999, well, look what's happening to my y values. F of x is going from -3, -6, -30, -300, -3,000, -30,000. This is just continuing to get bigger and bigger and bigger. Well, bigger in the negative direction, right? My next one would be -300,000, -3 million, right? Etc., etc. -30 million, -300 million, -3 billion. Okay, so it's just getting larger and larger in the negative direction. So what we say is the limit as x approaches 7 from the left of f of x. Well, so again, as my x values get closer and closer and closer to 7, what's happening to my y values? These are going to negative infinity. Okay, those are just also going to keep getting larger and larger in the negative direction. Okay, now similar thing, but instead of approaching instead of approaching 7 from the left, let's approach it from the right. All right, well, same thing. If I just try to plug in 7 here, I'm going to get 0. So let me make a table again. All right, so approaching from the right, so let's say I do 8. 8 minus 7 is 1. 3 divided by 1 is 3. Okay, great. Let's say I do 7.5. So 3 divided by 0.5 would be 6. Right. Let's say I get to 7.1. Right. 3 over 7.1 minus 7, so divided by 0.1, that'd be 30. Right. What about 7.01? It'd be 300. All right, what about it closer to 7? 7.001 would be 3,000. Okay, again, you can see the pattern. Right, it's very similar, but just coming from the right now. So as we get closer and closer and closer to 7 for my x values, our y values are going to positive infinity. Okay, so now it depends. We have to be very careful about if we are approaching from the left or if we are approaching from the right. Because if we're approaching from the left, then those values are going to negative infinity. But if we're approaching from the right, these values are going to positive infinity. So what we're doing is we're kind of creating a way, I said we would do this, we're kind of creating a way that we can consider what happens when we divide by 0. Right? It's still kind of a cheat, it's kind of a workaround, because we can't say that, you know, it equals infinity. Infinity isn't a number. You can't equal infinity, but you can approach infinity. You can go to infinity. So that's what ends up happening here. So depending on the one-sided limit we're talking about, this will either approach negative infinity or it will approach positive infinity. Find the limit as x approaches -3 for f. There's no function. What? I don't know what function was supposed to be here. Was this just leftover? Maybe I meant to delete this slide. Let's see. We did our 7. I don't know. I don't know. I truly don't know if this was supposed to be something or if I just meant to delete it. Probably just meant to delete it, but never did. Who knows? We'll skip it. Let's go to this piecewise function. This one's way more interesting. Look how prepared I was for this one. Right. Use f to evaluate the following expressions. All right, so f is a piecewise function. All right, which means that depending on what the x value is, we have different choices for which equation we'll use, right? We'll either use negative x or sine or cosine. Okay. Now, I wanted to do this because I know that you guys all perfectly remember your values for sine and cosine. I know that you guys have the unit circle completely memorized still from trigonometry. So I wanted to give you a chance to demonstrate that intense trigonometric knowledge. Right? Right. All right, so let's look at number 1. The limit as x approaches pi over 6 from the left. Okay, so so my first goal is just, okay, let's try to plug in pi over 6 to f, right? Remember, it doesn't matter if it's a left-hand limit or a right-hand limit or if it's just an overall limit. Your first attempt, what you should do is just try to plug in pi over 6. Okay, so I first need to make a choice. Which equation do I use? Well, which interval does pi over 6 fit into? Does it fit into here? Does it fit into here? Or does it fit into here? Well, pi over 6 is not greater than 2 pi. Pi over 6 is not between pi over 4. But pi over 6 is less than or equal to pi over 4. So we're going to choose this first equation. And luckily, that first equation is quite simple. It just says negative x. So we're just going to do negative pi over 6. The end. Wow. Well, Poppy says it must be right. Let me go back and fix this then. Number 2, the limit as x approaches 2 pi from the right. Okay, pay close attention if we're talking about from the left or from the right, especially in this equation. So my goal is to basically just plug in 2 pi, but hold on, this is a little bit different. Since we are approaching it from the right, okay, so we're talking about plugging in numbers that are slightly larger than 2 pi. So even though this middle equation, if I were just straight plugging in 2 pi, then I would use sine. But our limit is approaching it from the right. So we are plugging in, we're thinking about actually plugging in things that are just a tiny bit larger than 2 pi. So if we're plugging in things that are a tiny bit larger than 2 pi, then we want to use cosine. So cosine of 2 pi. All right, who's got their unit circle? What's cosine of 2 pi? Uh-oh, Matt's getting called out. One. I'm so proud. It's 1. You're both so smart. Shout out to Kim. Big shout out, Kim. Love that girl. All right, and my third limit, as x approaches pi over 4, this does not say a left-hand limit or a right-hand limit. It is just as x approaches pi over 4. So that means we need to individually do both limits. Whoa. So let's start by doing the left-hand limit. So pi over 4 from the left. So we're thinking about plugging in things that are slightly less than pi over 4. All right, so if I'm plugging in things that are slightly less than pi over 4, then I want to use this equation, which is just negative whatever the x value is. So this just equals negative pi over 4. And let's compare that to what happens if we take the right-hand limit. So as x approaches pi over 4 from the right, so as we plug in things that are slightly larger than pi over 4, then we're going to use this middle equation. So that's sine of pi over 4. All right, unit circle time. What's sine of pi over 4? Nice. Root 2 over 2. Uh-oh. Shout out to Kim. Okay, so looking at the left-hand limit and the right-hand limit, we can definitely see that these are not the same value. So since they are not the same, that means this limit does not exist. The answer is always 0, asserts Megan. You know, maybe. I'd say probably not, but maybe. Zero gummy worms today. Really? 0 sleep. Wow. How many ounces of cheese did you eat? Same. I feel like I got 0 hours of sleep. I had salad with some cheese. Okay. Okay, so that's just some basic algebraic limits. It gets a little trickier if we have a piecewise function, because depending on if we're coming from the left or from the right, it'll change what equation we're using. And then sometimes those two sides will match up, sometimes they won't. It just depends.